Hello, welcome to my channel, Taxonomy Online Mathematics, continuation of our logarithm function. We are taking the basic properties, some few basic properties of what? Logarithm. So let x and b be a real number such that b must not be 0, must be bigger than 0. Then it must also not be what? 1. Simply put, in our earlier episode, we defined that the b must be a positive real number, but not equals to 1, meaning we need more than what? 1. All right, so let's just take, for example, we take a logarithm of 1 to the base b. What would this value be? It's a property we are trying to develop, that a logarithm of what? 1 to the base b. What will it give us? From our earlier episode, we mentioned that it is a logarithmic what? Function. Therefore, we can write it as what? An equation. So if we let the whole of this equals to y, let's just use a variable. Then it means here we can convert the logarithm into indices by repeating the base, right? Which is going to be the base b, exponent y equals what? 1. Right? Now, we know 1 can also be written as what? Exponent of a number to the exponent of what? 0. Meaning, I can write this, for me to be able to write this, what will it be? I can also say that b exponent 0 give me what? 1. So instead of writing 1, I can write b exponent 0 here. So let's go. B exponent y equals to b exponent what? 0. From the onset of indices, we know that if I am having equation that has a base that are the same, then it means the exponent must also be what? The same. So right away, I will say y equals what? 0. So if y is equal to 0, I can remove this y and make it 0 to mean that the logarithm of 1 to the base b must give you what? 0. That's the first word, property. That the logarithm of 1 to the base b. B in here is standing in for all real numbers that are more than 0 but not equals to what? 1. So your mind is thinking 2, 10, 20, 100. All those numbers that could be a base. If I have a logarithm 1 to any base at all, I am going to get what? 0 from this explanation, migration from indices into logarithm. We know this could also be written as log 1 base b equals 0. So let's get that. Then let's have the second one. Let's say I'm having the logarithm of b to the base what? B. Then I am going to introduce a power. I want to introduce a power, meaning I am having logarithm of b exponent x with the base what? B. What value will I get if I am to be given this? Don't forget the b stands for any number, any real number at all. So this, we can also say that let the whole of this equals to y, so that we can remember the conversion from this into indices. B exponent y equals to what? B exponent what? X. So obviously, seeing this, you know that seeing this is exponential equation, base, the exponent must be the same. Meaning y should be the same as what? X. So in all, if I have a logarithm of b exponent x to the same base, I should be just interested in what? The x. So in this, we can say that if I take an example, logarithm of what? 5 exponent 3 to the base 5. I believe the answer will be 5, right? No, the answer will be what? 3. Because the base and the argument are the same. So since I have 5 and 5, I'll be interested in what? Only the x, which is the exponent I'm having here. So this will just be equals to what? 3. We have another way of which we can get the 3 without following this procedure. That will be under the law, the third law, but we are concentrating on what? The properties. So property 1 is a logarithm of what? 1 to the base what? B, or any number, give us what? 0. Then we are also going to say that if I have a logarithm of b being a base having an exponent of x, and the logarithm have the base b, then I am all going to have what? This value x to be my answer, as we can see in this stage. Let's say in this case we are having b as a number which is having a power of what? Logarithm. The exponent is a logarithm. Then the exponent also have what? X and a base b. The attention here we are looking for is that the base of the logarithm, which is the exponent in this case, is the same as the base of the indices. So this is the indices. Let's take it as indices. Base b, exponent, logarithm function, right? And the logarithm also have x as a number and b as a base. So the moment the base of the indices is the same as the base of the logarithm, the property we are going to talk about here is going to come into play. All right, so what do? We can say that let all this be equal to a certain variable, which in this case we can call what? Y. So if y is the case, what do? We know that if we are taking 2 exponent 3 equals to 8, you are seeing it? B is our 2, the exponent is here, y is our what? 8. If you are going to write this, you still have to write logarithm of what? The base 2, the number 8 equals what? 3. Let me see if we can be able to translate this in this form, right? So it's going to be that the logarithm 2 is a base here. It becomes the base. So b becomes the base, right? Do we see that? Then y, which is the 8, is becoming the number. So here we have the number what? Y. What are we looking for? We are looking for this to be the answer, to be equals to the logarithm of x to the base what? B. Do we see what I'm saying? I believe you can see that translating from here, 2 being the base, it is still the base of the logarithm. 8 being the exponential form, become the logarithm function here equals to 3 as the exponent. So the same thing we are doing here. This is the base. This is the function, the exponential form, and this is the exponent. So the whole of this become that. But you can see in this case that if we take the logarithm to be x, no, I have x here. Let the logarithm be what? K. It means it will be ky equals to kx, where the k are common. So what do? We cancel the k out, or we divide both sides by k. In this case, the k will be eliminated. So I'll be left with only y equals to what? X. But don't forget our y is now x. So it means the whole of this become x. So in the actual sense, if I have b exponent of log x to the base b, I am only going to get what? X. Since we are replacing the y with what? X. This becomes the exponent. So the catchword is that the base of the logarithm should be the base of the number. Then you will only pick the argument as your answer. No two ways about that. I believe that is clear. Good. Thank you for watching. Like the video if you find it educative. Share with your learning mate. Subscribe to the channel. Follow me on YouTube, Taxonomy Online Mathematics, Facebook, Taxonomy Online Mathematics, TikTok, and other from the same name. Come back to this place for the laws of logarithm. Bye-bye.